can find out what is the shunt, children. So that is what we are going to do. Okay. So who can tell me the relationship for shunt? How to find out, the relationship? What is the relationship instead of try to find out? This is the relationship, the formula. If anybody can remember and tell me, feel free to communicate. Yes, we have seen it while revising the concepts. Yeah. No idea to find out what is the shunt resistance. There is a relationship, right? The formula sheet, have you guys gone through it? Formula for shunt. Okay, so I'll put it on the screen. So formulas, please go through it, children. Okay. So when we say shunt, resistance, the amount of current that shunt resistance should be carrying. So we have the relationship which tells you the current through the shunt is I minus Ig, the total current flowing minus the galvanometer current. That's it. So by using that particular relationship, we can directly find out what is the resistance of shunt that needs to be connected. Okay. So just put it here on the screen. So there is a particular relationship. So the current passing through the shunt is nothing but I minus Ig. Say current passing through the shunt is equal to total current minus current through the galvanometer. Okay, this is the basic relationship for the current that we have. But we wanted the shunt resistance. Shunt resistance, you can take it as S also. Okay, so we will make use of that. So we get the ratio as I upon Ig. I'll just put it. Okay, I upon Ig is going to be equal to the galvanometer resistance plus shunt resistance upon shunt resistance. Okay, because the total current is sum of the current through the galvanometer and sum of the current passing through the shunt. So making use of this, so we can find out the value. Okay. So here, this is the relation that we get. Now we just go for a rearrangement and then simplify it. Okay. So when you go for a rearrangement, you can see that I times S is equal to Ig into G plus Ig into S into shunt. So here we won't want to find out what is S. Make S the subject, shunt resistance the subject. So you get S times I minus Ig is equal to Ig into G. So you can find out the shunt resistance using this relation. So it's Ig times G upon I minus Ig. So this is the formula that we use to find out the shunt resistance. Okay. So here, this is where you have your ammeter. This is the diagram. So we are connecting a resistance in parallel with it, provided the current flowing through the ammeter. The ammeter is going to have some resistance. So we are taking that resistance as G. This is your shunt resistance R. The incoming current is going to be I. As current will get branched at this node or at the junction, current passing through the shunt is what we try to understand. So here, when the current is passing through this, say the main current passing through galvanometer of or through this particular instrument, so I take it as Ig. If I take this as Ig, the balance current will be I minus Ig. That's it. Okay. So using this particular relationship, we try to find out what is the value of shunt. So we are applying the KCL, KVL, and we'll get this relationship. That's what I showed you here in steps. So here you go and substitute children. Now from the question, what is the data that we have? The resistance of the ammeter means the G value is what they have given. So G value is given as 13. So G is 13. Okay. And you can see its scale is graduated for a current up to 100 amperes. So until 100 amperes, it is graduated. And we try to make it measurable until 750. So until 750, if you want to make it measurable, so what do you do? So the current I is nothing but 750 amperes. Okay. And IG, primarily it is just 100 amperes, right? Let me check. Yeah, until 100 amperes. So that we have it as 100. And now you go and substitute all the values that we have in this formula. So when you go and substitute, what happens? You get S equals to, so IG is 100 and G is 13. So 100 into 13 upon 750 minus 100. Simplify it. Okay. How much do you get, children, if you simplify this? What is the value of shunt that you're getting? So 1300 upon 650. Right? So go for the simplification. 130 upon 65. What is the value that you're getting? Yes. You're getting 2, right? Are you guys getting 2 ohms?
Yes, sir. 2
Yes,
ohms, sir.
2 ohms you're getting? Yes. So you'll be getting 2 ohms. So the answer is option D. Okay. So option D is 2 ohms. So 2 ohms is basically the amount of shunt that needs to be calculated to here for the conversion. Okay. So the answer is 2 ohms. This is how you do it. Okay, so the formula, this formula you should keep it in mind. Or generally we can derive this formula on the spot also, but to save time, it's better that you remember this formula. Okay, so let's now move on to the next question, children. I hope this part is clear. So going to the next question. So second question for the day. Here we go. Yes. The heat produced, okay, the heat produced in a resistance, the heat produced, say this is in calories, okay, in calories, in a resistance R, in a resistance R, when a current, when a current I, okay, when a current I flows through it, when a current I flows through it, okay, flows through it for t seconds, for t seconds is given by the expression, is given by the expression. So here there are different expressions which have been given as options. So first option, I square RT upon 4.2. Option B, I square RT, okay, sorry, I R square. These options different. It is I R square into T upon 4.2. Option C, 4.2 into IR upon T square. And option D, it's IR T square divided by 4.2. So these are the options. Okay. So here they are asking you what is the heat produced. They have specifically mentioned that heat is produced in calories. So in calories we are going to write down what is the heat produced. We try to identify what is the correct expression. So what is the formula for heat? The general formula for heat, anybody?
I r square t.
Okay. Yes, IR square. So IR square into T is the general formula. Here, the conversion from joule to calories is what you guys should take care. Okay. So that conversion only we are trying to keep in mind. So if you try to go for the conversion from joules to calorie, primarily it will be in joules. So if you go for conversion to calorie, the factor of 4.2 comes. Okay. So which one do you think, children, will be the answer here?
Sir, option B. I need to.
Yeah, option. The last option or the second option?
Sir, I think it's second option.
Second option. Okay, we'll look at it. So here, if you can see here, so I square RT is what you guys said is right. Okay, I square RT is definitely correct. That is the heat formula. Okay, so here if you see which option there is I square RT, check about it. Go by the method of elimination. Okay, first option you have I square RT. Okay, here it is there. Second option it's different. That's wrong. The way it's written, it's wrong. Third is also wrong, right? Fourth is also wrong. The way it has been expressed. So the correct option by method of elimination is option A. Is that clear? So that's how you go with the method of elimination. So heat is nothing but power into time. That's the formula. So power dissipated when you say it is I square into R. Already it's multiplied with time, and hence I square RT is the heat dissipation. So the answer is I square RT. Okay. So that option is option A. So upon 4.2, that 4.2 is basically a conversion. Okay, the factor of conversion, and that is in the denominator. Okay. Now moving on to the next question. This was a simple one. So let's go to the next one. Here comes question number 3. Putting it on screen. Okay. Look at it. Come back. So here's a question. If all meters, if all meters are ideal, if all meters are ideal, and the reading of the voltmeter and the reading of the voltmeter voltmeter 3 is 6 volts, then power supplied by voltage source, then power supplied by voltage source power supplied by the voltage source is. So you have to calculate what is the power supplied by the voltage source, provided one of the readings is given. So here there is a figure, children, for this. So I'm just putting the figure here. So A is ammeters. Wherever I put B, they are voltmeters. Okay. This is the entire circuit. Okay, I'm giving you the values of the resistors. 10 ohms. On the top it is 20 ohms. Okay, and I'm numbering, the instruments. This is 2, this is 4, 5, and voltmeter you can see the voltmeter is 3. This is 3 and 1. So the voltmeter 3, they have given in the question the reading is 6 volts. So 6 volts is the reading of the third voltmeter in the figure. Okay, and there is a voltage source here. Okay, this is the voltage source. So you should calculate what is the power supplied by the voltage source. Okay, I'm giving you the options. First option, 10 watts. Second option, 38 watts. Option C, 20 watts. And option D, 30 watts. Okay. So first, in the question, you have to find out what is the power supplied by the voltage source. So analyze the given circuit here, and then carefully you have to find out what is the power supply of the voltage source. Okay, that's it, children. So given one of the data, you should find out the other. So what is the formula for power and how can we approach this? Yes, the step-by-step approach, easily you can do it. It's not a big deal. Okay, so based on the circuit, so we will simplify the circuit and then we try to find out. So look at the circuit. What can you find in the circuit? There are different components. Some elements are in series, some elements are in parallel, right? So based on that, we can go for simplification. Okay. Who can tell me the current through 20 ohms, children? What is the current passing through this 20 ohms resistor? On the top, you can write a relation for the current. What is the current passing through 20 ohms? They have given us the value of voltage source. If they are telling this is 6 volts, can't we understand that uh, the potential in parallel combination is always the same, right? As per the rule. So you know that the potential of components in parallel combination, all of them are same, right? So across 20 ohms, the potential is 6 volts. Across 10 ohms, also potential is going to be 6 volts. You understand that? So we make use of that relationship. So current passing through 20 ohms will be, I'll just write it down. So what is the current passing through this 20 ohms resistor? You apply the Ohm's law, right? So if you apply Ohm's law, what will you get? So I is equal to V upon R. V is 6 volts. So 6 upon 20. That is going to be 6 upon 20 amperes. Is that clear? That is the current passing through 20 ohms. Same way, what is current passing through 10 ohms resistor? At the bottom, can you see? So what is the current passing through that? The current passing through 10 ohms resistor is equal to, again, I is equal to V upon R. V is 6. So 6 upon 10. So 6 upon 10 amperes is basically the current. Okay. So if you have these two currents, so what is going to be the total current? Just add them, right? I1 plus I2. So that will give you the total current. So if you add them, so 6 is anyways common. So 6 times 1 upon 20 plus 1 upon 10. So that is going to be the total current. Okay. The total current of the voltage source. So simplify this. How much is 1 by 20 plus 1 by 10 times 6? Go for a simplification. Take the LCM, children. So you will be getting this value answer as 0, I think 0.9 you will get. Okay. To simplify, you will get this total current as 0.9 amperes. Okay. So I total is 0.9 amperes. Total current is 0.9 amperes. What is the voltage of the battery? The voltage also I want. So how to find out the voltage? Again, look at the circuit. The left side, the voltmeter is 6 volts, which we have, right? So that is 6 volts. Then what is the remaining on the right side? How do you find out that? How do you find that out? there is an ammeter, and then you also have a resistance of 30 ohms, right? So what will be the potential across 30 ohms? Find out the potential across the 30 ohms component also. Okay, that is the potential across 30 ohms. So again, you know that according to the formula, V is equal to I into R. So making use of that relationship, can't you find out what is the potential across 30 ohms? So V equals IR, right? Ohm's law itself you use. I, total current we have just now found out. Total current is nothing but 0.9. So it is 0.9 into 30. How much is 0.9 into 30? 9 upon 10 into 13. So 9 threes are, you get 27 volt. Is that clear? So the potential across 30 ohms resistor is rather 27 volts. So the total potential is going to be 6 volts plus 27 volts. How much is that? 6 plus 27. So 33, right? So 33 volts is the total potential. So we have found out the total current, we have found out the total potential. So we can easily find out what is the power supplied by the battery source. So power supplied by the battery source is going to be, you can make use of the relationship V is equal to V into I, the first formula for power. So power can be expressed as the product of potential difference and current. Simple. The potential difference is 33 and the current is 0.9. Right? So what's the answer? So 9 upon 10 times 33. So 9 upon 10 times 33. So how much you are getting? So you will be getting this value as 33 into 9 upon 10. So go for a simplification. 3.3 into 9. So how much is 3.3 into 9, children? Multiplied 297 upon 10, right? So 29.7 you can write. So 29.7 watts. Okay, we got 29.7 watts. Go to the options. Which option is the closest answer? 29.7 means it is approximately 30 watts, right?
The 30 watts, sir.
Yeah, so it is 30 watts over. So the answer is option D here in this case. So option D is your answer. That clear? So this is how you approach this question. So we are going by a step-by-step approach. First we found out what is the current, the total current in the circuit. How did we do that? The current passing through 20 ohms to 10 ohms we found out and we added them. So by adding them we could find out what is the total current in the circuit. And then we found out the battery, the total potential of the battery source. So here, the cell, the total potential of the voltage source, we found out by adding both the potential 6 volts plus potential across 30 ohms resistor, which we found out using Ohm's law as 27. So we added both, we got 33 volts. And then we made the use of formula for power as V into I, product of potential and current, and we found out power as 30 watts. So this is how we solve this question. Okay. So now we move on to the next question. Putting it on screen. So question number 4. Here we go. Yes. Two spheres of radii 2 centimeters and 3 centimeters are charged to the same potential are charged to the same potential, full stop. If sigma 1 and sigma 2 are surface charge density, are the surface charge density on the conductors, that is on the spheres, on the spheres, then then ratio of sigma 1 upon sigma 2 will be. Then they are asking you what are the ratios of the surface charge densities on the spheres. So here comes the option. First option 4 by 9. Second option 2 by 3. Third option 3 by 2. And fourth option 9 by 4. So these are the options. Okay. So now look at the question, children. By looking at the question, you can see that they have clearly mentioned there are two spheres and they have given you the radius of both the spheres. Okay. The first and the second sphere's radius is being given. Okay. So by having the value of radius, they are asking us to calculate what is the ratio of the surface charge density. The ratio of surface charge density they are asking us. So we need to go for the relationship and then we need to find out what is the ratio of surface charge density. That's all. Okay. So how do we approach this question? So when there are two spheres with two different radii, so here there is a relationship for potential, children. Okay. So potential is relating, the surface charge density. So how can we write down? We can write potential relating surface charge density. So we can say V is equal to sigma R. Okay. So sigma R upon. So sigma is the surface charge density, R is the radius. So sigma R upon epsilon naught. Okay. Upon epsilon naught. So we can write them like this. Okay. So directly I have written the relationship. But how this came? We have the relation for potential as V is equal to KQ by R. If you guys can relate, this is the basic formula. And now here I have just substituted the value. When you say surface charge density, this sigma is nothing but the charge per unit surface. Okay. So the charge acting per unit surface area. So that is what is the general formula. So when I say surface area of the sphere, I hope you guys know the formula for the surface area of the sphere. Surface area is nothing but 4 pi r square, right? So this is the relationship. Okay. So here in terms of radius, we are trying to express. So you go here, you substitute, children, in this particular formula. What happens? So again, this formula will get reduced to V is equal to sigma R upon epsilon naught. I have showed you the reduced version of the formula. Okay, you go and take and substitute it back in for the charge, you will get this relation. Okay. So now, say, let us take first charge potential as V1. So V1 is equal to sigma 1 times R. For first sphere, what was the radius? It was 2 centimeters, right? So sigma 1 into 2 divided by epsilon naught. Same way we can write V2 is equal to sigma 2 into what was its radii? Its radii was 3 centimeter, right? So sigma 2 into 3 upon epsilon naught. That's it. Now here in this question, they have given us one hint. One relation is there. What is the relation? They are saying both of them have same potential. What is the meaning of this statement? If both are same potential, then we can equate both the V's, right? So V1 is equal to V2. Go to equate them. Then what do you get? Sigma 1 times 2 upon epsilon naught is equal to sigma 2 times 3 upon epsilon naught. That's it. So what gets cancelled here? Epsilon naught gets cancelled and you get sigma 1 upon sigma 2 is equal to 3 by 2. Is it clear, children? This is how you find out the ratio of surface charge densities. And what is our answer? The answer is 3 is to 2. So option C is the correct answer. Is that clear, children? This is how you approach this particular question. Okay. The answer is 3 upon 2. This is how we got the relations. Okay. So I've shown you the method of how to approach this question. Right? So when I talk about volume charge density, who can tell me what's the formula for volume charge density? Instead of surface, they have given volume charge density. So what happens to this relation in that case? Volume charge density is nothing but the ratio of charge per unit volume. So there you will write volume of the sphere formula. Instead of 4 pi r square, you will put 4 by 3 pi r cube. Okay. So appropriately the formula changes. Okay. Now let's move on to the next question. The next number 5. So here comes the next question. Putting on the next question on the screen. Here comes question number 5. Okay. A circuit is connected. A circuit is connected as shown. Circuit is connected as shown with switch open. With switch S open. Okay. There is a circuit, but they're telling the switch is open first. Okay. Then when the switch is closed, when the switch is closed, when the switch S is closed, the total amount of charge, the total amount of charge that flows the total amount of charge that flows from Y to X, from Y to X is, okay, they're asking what is the total amount of charge that is going to flow from Y to X. I'm first putting the figure here, and then I'll give you the options. So these are two capacitors. Okay, the first capacitor is 3 microfarad. Second capacitor is 6 microfarad. Okay. Now in between these two, there is a switch. This is switch S. Now at the bottom, there are two resistors also, as shown. So the values of the resistors are 3 ohms and 6 ohms. Okay, this is the circuit. Now this entire circuit combination is connected to a 9-volt cell. There is a 9-volt cell, children. Okay, this is the circuit connection. So the point X is here, and this is point Y. That is the figure. So this is the figure, children. So this is your circuit. You can see that there are two capacitors in series combination, and that entire combination of two capacitors is connected in parallel with two resistors in series of 3 and 6 ohms. Okay, and this combination is connected to a 9-volt battery as shown, and X and Y are 2 points in between, which is connected with a switch. So having this condition, they are asking you what is the charge that is going to flow from Y to X. Okay, so from Y to X, what is going to be the charge that is going to be flowing is the question. I'll give you the options, and then we will try to analyze this question. Okay, so you people make a note of this figure, try working it out. Meanwhile, I'll give you the options. First one, option A is 0. Option B is 54 microcoulombs. Option C, 81 microcoulombs. And option D, 27 microcoulombs. Okay, these are the options. Now, what is the charge that is flowing from Y to X? That is what we will have to find out. Okay, anybody? How do we find out what is the charge that is flowing from Y to X? Again, look at the combination of capacitors. Once you have the combination of capacitors, easily you can decode and you can find out what is the answer. Okay. So when the switch was open, how the circuit was, and when you close the switch, what happens? Okay. So how much amount of charge is going to? That's it. So what is the current, children? When switch is open, what is the current? Yes.
Zero, sir.
Okay. When the switch is open, the amount of current is going to be, you are saying it is 0. Okay. But how it is going to be 0? Look at this figure. The switch is here in between, right? So definitely there is some amount of current that is going to pass. When the switch was open, definitely there is some current. So how to find out that amount of current? So by having this resistors combination, easily we can try to find out what is the amount of current. Okay, when switch is open, definitely the current is going to pass like this, right? So you have amount of current passing here, and then here the current gets split, say I1 and I2. Okay, so you can find out the current that is going to flow through it. You can find out when switch is open, because switch is here. It is not disconnecting the cell of 9 volts. 9 volts is definitely engaged, whether it is closed or open. 9 volts is definitely there. Are you getting the point? So we can find out what is the current through 3 ohms and 6 ohms, because both are in series combination. Total series combination is going to be R is going to be equal to 3 plus 6, which is going to be 9 ohms. If this is 9 ohms, if potential is going to be 9 volts, what is the current using Ohm's law? I is equal to V upon R, right? So 1 ampere, right? So 1 ampere current is definitely there. When switch is going to be initially open, so 1 ampere current is definitely flowing through 3 and 6 ohms resistors. That is the meaning. Okay, so provided 1 ampere current is flowing, now they are asking you what is going to be the charge when the switch is closed. So when you close the switch, what is the amount of charge that is going to flow? Okay, so that is what we try to find out. So find out what is the amount of charge that is going to flow. Simple. So how do you approach this? There are two capacitors on the top, and both the capacitors are in what combination? Both of them are going to be are in series combination. So in series combination of capacitors, what is same and what is different? I hope you guys will be knowing. In series combination of capacitors, which parameter is same and which parameter is different? Okay, when they are arranged in series, which component is same, children? Yes, we have learned. We know that charge Q is equal to C into V. That is definitely known to us, right? So in series combination, what are same of capacitors? When capacitors are connected in series, the magnitude of charge on each capacitor is the same. Okay, this is an important rule. Without this rule, we cannot solve this. Okay, so based on the basics of capacitors, we know that whenever you have two capacitors in series, then the charge on each of the capacitor will remain the same. Are you getting it? Whatever charge is on 3 microfarad capacitor, the same charge will reflect on 6 microfarad capacitor as well. Okay, that's it. That is the main agenda. Having this information, so we can easily find out what is the relationship. So what is the total effective combination of these capacitors? You have two capacitors in series. So effective capacitance formula, I hope you guys might be knowing. So 1 upon C effective is equal to 1 by C1 plus 1 by C2, right? When they are in series combination, we use this particular relationship. So 1 by C1 plus 1 by C2. We make use of this relationship. You take the reciprocals, children, and then find out what is C effective. If I take reciprocal and do it, so how can I write? C effective is equal to C1 C2 upon C1 plus C2. Are you getting it? That's it. This is what we do. So what is C1 C2? 3 into 6, right? 3 into 6 upon 3 plus 6, which is 9. Okay, so I can go for a simplification. 3 ones are 3 threes are, and 3 ones are 3 twos are 6. So how much is the effective capacitance of this combination? It is 2 microfarad. Are you getting it? First you find out the effective capacitance. Once you find out the effective capacitance, then you compute what is going to be the charge. And what's the formula, children, to find out the charge on the capacitance of the capacitor? You know that Q is equal to C into V. Yeah, so using the formula Q is equal to CV, you can find out what is the total charge on the capacitance of this combination of capacitance. Okay, so use this formula. So capacitance, total capacitance is 2 microfarad. So 2 microfarad into the potential, the cell potential that you're having, right? So what is the cell potential? It is 9 volts. 2 microfarad into 9 volts. So how much it is? So it is 18, right? So 18 micro, because micro is there, you put that also. So it is 18 microcoulombs, right? That's the unit of charge. So the effective charge is basically 18 microcoulombs. Now this 18 microcoulombs that we have basically found out here is what? The total effective charge on this combination of capacitors. Okay, so we have found out the total effective capacitance, I mean total effective charge by using this relationship. Okay, so what is the answer? So here effective we have found out. When you have two different capacitors here, in that case what will be your answer? Two capacitors are there. For 3 microfarad is there, 6 microfarad is also there. And total charge when you have, so here the amount of charge that is going to flow from Y to X. Okay, so 18 is basically for the entire. Okay, so the charge on each of them. So the moment switch is going to be connected, immediately the charges will get this. The charge gets discharged. Whatever charge is accumulated is going to get discharged. Okay, so it gets discharged and it is going to flow. So you can tell me what is the charge that is going to get discharged and that is going to flow through it? Yes, children. The moment switch is kept closed, when you connect the switch, how much amount of charge is going to flow? Is it 18 or twice of 18? How much it is? Or half of it, or just one of them is going to flow, because you can see the switches in between. Yes, so we have done almost. So when you say the effective charge is 18 microcoulombs, and when the switch is going to be kept closed, that is when you are keeping the circuit closed. So how much amount of charge is getting transferred from Y to X? When they are asking the other way around. Now generally X to Y, we can directly say the answer is going to be 18. But when they are asking in the reverse direction, so you will have to go think, and then you will have to approach. So how much charge is getting transferred the other way around? Okay. So how do you calculate in that case? Because there is a 1 ampere current that is also passing through 3 and 6 ohms resistors. So when from Y to X, if you want to find out what is the amount of charge that is going to flow, so I is equal to Q upon T. So immediately within a fraction of a second, when you're going to discharge the entire combination, so here it is actually 27 microcoulombs. So 18 plus that extra component of charge is also going to flow. Okay, so answer is not actually 18. Okay, so the extra component also needs to be considered, children. That is for that 9 volt, that 9 coulomb charge also you will consider. Okay, the small 9 microcoulomb of charge also we basically consider for the resistive components, because there is 1 ampere of current that is going to be transferred. So for that 1 ampere current combination, you have an additional charge. So the charge getting, I'll put it as Q y x. So y to x is equal to 18 microcoulomb plus, so additionally we also have the 9 microcoulomb charge that is going to be there. So for this 9 microcoulomb, that is because 1 ampere of current is there, is passing through 6 and 3 ohms, which is in series. So that also needs to be taken into account when you're trying to find out the charge which is getting passed from Y to X. So the total charge is going to be 18 plus 9. And how much is that? 18 plus 9 will give you 27. 27 microcoulomb is actually the answer. So 27 microcoulomb is the answer. This is a little tricky question. So here, when they ask you from Y to X, you look at what amount of current is passing through it. So based on the amount of current, you can find out what is the charge that is going to exist here, and charges in terms of microcoulomb only we express them, because the entire combination of capacitors here also is in terms of microfarad. So here 18 plus 9 will give you 27, and that's your answer. So option D, 27 microcoulomb. Okay, it was a tricky one. So you have to practice such questions, only then you will get it. Okay, so now moving on to the next question. We look at the next question, children. Okay, putting up the next question here on the screen. Okay, so let's see the next question. Yes. So this is basically, based on 11th standard topic. Okay, I'll just put it up here. The escape velocity. Okay, the stylus is calibrated. Hang on. Yeah, the escape velocity. Okay, the escape velocity of a body on the surface of the earth on the surface of the earth on the surface of the earth is 11.2 kilometers per second. Okay, if the earth's mass increases to twice its present value, then and radius of the earth becomes half, and radius of the earth becomes half, okay, then escape velocity becomes what happens to the escape velocity? What is the value then? So the options are, first option A, 5.6 kilometers per second. Okay, option B, 11.2 kilometers per second. Option C, 22.4 kilometers per second. And the option D is 44.8 kilometers per second. These are the options. Okay. Now go through the question. So here in this question, 1 second, children. Let me reshare it. Yeah. So here, now based on the question, here what are they saying? They are saying that the escape velocity of the body on the surface of the earth is given. Now they have just done a small, change here. What have they done? They are told that the radius is becoming half, but the mass of the earth becomes twice than what it was before. So subject to these conditions, they are asking what is the new escape velocity. Okay. So subject to these conditions, the value of new escape velocity needs to be calculated. All right. So what is the value of new escape velocity? Yes, what would be the value of new escape velocity in this case? Anybody knows the formula for the escape velocity? Yes, children. It is under root of 2gm upon r, right? That's the relationship. Formula for escape velocity is, the general formula is P is equal to under root of 2gm upon r. That's all. Okay. Under root 2gm upon r is the formula. So they have given the general, the value for this escape velocity is 11.2. That also they have specified in the question. This is 11.2 kilometers per second. That is also given. Now what they are telling? They're telling our mass is not m anymore. They're telling your mass is replaced with 2m, but radius is also becoming half than what it was before. So new radius is r upon 2. Subject to these conditions, what happens to the new escape velocity is the question.
Sir,
Then what
option
happens?
C.
Option C? Yes, option C you're getting? Okay, good. So here, under root of, what do we do, children? 2g, in the place of m, I am putting 2m, right? So you put 2m, twice than what it was before. And r is r, but r upon 2. Simplify this. So what happens? The 2's are 4, you can bring it out, right? So you will get 2 under root. Again, you will get gm upon r only, right? 2 upon 2 under root 2 gm upon r. So what happens here? So it is 2 into, you know that under root 2 gm upon r is nothing but the same escape velocity, which is 11.2. So 2 into 11.2 will give you the answer, which is 22.4. That's all. So the answer is 22.4. Option C, as you said, is right. Good. So that's the answer. So option C is the right answer. Is that clear, children? That's how you approach this question. Okay? So option C, 22.4 is the answer. And that's how we approach it. Okay? So formula should be in mind. Subject to the given conditions, you substitute and simplify, you get the new relationship, and substitute the values, you get the answer, the final answer. Okay? So now moving on to the next question. Question number 7. So putting it on the screen. Okay? Here comes the next question. An iron rod of length 50 centimeters, okay, of length 50 centimeters is joined at an end to an aluminium rod. Okay, to an aluminium rod of length 100 centimeters. So aluminium rod length is 100 centimeters. Iron rod they are given 50 centimeters. Okay. All measurements refer to 20 degrees Celsius. All measurements refer to 20 degrees Celsius. Okay. The coefficients of linear expansion of iron and aluminium are. They have given you the coefficient of expansions here. So coefficient of expansion for that is coefficient of linear expansion. Okay, coefficient of linear expansion for iron. So I'm writing it like this: alpha Fe is equal to 12 into 10 to the power minus 6 degrees Celsius inverse, and coefficient of linear expansion for aluminium is given as 24 into 10 to the power minus 6 degrees Celsius inverse. These are the coefficients of linear expansions of both iron and aluminium. Okay, now the question is the average, okay, the average coefficient of expansion of the composite system is, what is the average coefficient of expansion of the composite system? So we need to calculate that. So I'm giving you the options. The first option, 36 into 10 power minus 6 degrees Celsius inverse. Second option, 12 into 10 power minus 6. Third option is 20 into 10 power minus 6. And fourth option, 48 into 10 power minus 6. Okay, these are the options. Now here in this question, what are they trying to tell? So what we try to understand, So we see that there is an iron rod of 50 centimeter length is joined at the end of an aluminium rod of 100 centimeter length. So both end to end of iron and aluminium being joined is 150 centimeter total length. Okay. Now the entire system is in 20 degrees Celsius. So they've given you the temperature of these both is 20 and the linear expansion of both of them is given. The question is what's the average coefficient of expansion of the entire system when both are joined end to end? That is the question. Okay. So when you join them end to end, excuse me, yeah, what is the value of the system is what is the question. Okay. So how can we approach this? So total length you should find out. Okay. It's not so when you directly add them, you will get the total length, no doubt about it, right? So you add them end to end, you will get the total length. But that small increase in length also you should calculate. Okay. So increase in length for the first rod, the increase in length for the second rod also you have to basically find out. So final length you calculate. Okay. After it is increased, so what is the length? So length of the rods you are going to calculate. Okay. So if you calculate the length of the rods, what do you get, children? The reference when they are giving always is when they refer to 20 degrees Celsius. Okay. So always you do it at 100. So 100 is basically your final temperature. Initial temperature only is 20. Okay. The final temperature is 100. Alright. Because until specified, you take the final temperature as 100 degrees only. That's the reference. So having that, you can find out what is delta T. What is delta T? Final temperature minus initial temperature. Delta T is going to be fixed for both of them. So it's 100 minus 20, which is going to be 80. So 80 is your change in temperature. So similarly, find out what is the values of the first rod and the second rod. So both of them we try to find out. So make use of the formula, coefficient of linear expansion formula. What is the formula, children? You know that L is equal to final length is equal to initial length times 1 plus alpha delta t, right? That is the formula, isn't it? So I give you here, so final length is equal to initial length times 1 plus alpha delta t. So you need to use this particular formula. Okay. So final length we calculate. Initial lengths are given. Initial length for aluminium rod is going to be 50, and for the iron rod is going to be 50, right? And for the aluminium rod it is going to be 100. So provided this, you have to calculate, children. You go and substitute and find out what is L1 and L2. So L1 I am referring to iron. Okay, the final length of iron rod, and L2 we take it for aluminium rod, the final length of aluminium rod. Okay, so for iron rod it is going to be 50 times 1 plus alpha times 18. Same way here it is going to be 100 times 1 plus alpha into 8. So you substitute both of them and you simplify, you will get the values. The final length of iron, final length of aluminium you will get. Okay, you have to substitute and simplify for this. Okay, for iron the answer is found out to be 50.048. Okay, I'm writing here 50.048 is the final length. Same way here also it is 100 point. I'm giving the answer itself. So that is 100.192 children. Okay, these are the values. Okay, I'm giving you the values. Okay, once you simplify and you will get this particular values. So now here, once you have both the values, now what is going to be the total length of the system at 20 degrees Celsius? You tell me. Total length at 20. How will we find out? That is from the question itself you can find out. Total length at 20 degrees Celsius at initial temperature is direct 50 plus 100, right? How much is that? 150 direct. So 150 meters. But total length at final temperature. What is the total length at the final temperature? Okay, total length at the final temperature. So how do you find that total length at final temperature? So it's going to be, again, your change in length you have found out here, right? It's 50.048, 100 degrees Celsius. The total length is going to be 50.048 plus 100.192. So you need to add both of them. So how much is that? Add these values. So you will be getting 150.24. So it's 150.24. I'm substituting here. 150.24 meter is the total length. Okay, at 100 degrees Celsius. So once you found the total length at 100 degrees Celsius, you can find the average value of the coefficient of linear expansion of both the entire system. Okay, simple. So for that we need to find out change in length. So coefficient of linear expansion is nothing but change in length upon, you go, I'm rearranged and I'm writing change in length upon the total length times delta T. That's it. So change in length. What is the change in length, children? Is 150.24 minus 150. So what is the change? It is 0.24. Are you getting it? And total length is 150. Okay. So here 150 or 150.24 you take. The total length is 150 itself at the initial temperature. Okay. Into delta T is nothing but 80. Okay. Substituting into 80. That's it. So simplify this. What is the alpha? That is the answer. Okay, you have to simplify this corresponding value. I'm giving the direct value. So go here, substitute and simplify, children. So you'll be getting 20 into 10 power minus 6. 20 times 10 power minus 6 degrees Celsius. And that is your answer. So this is the answer. 20 times 10 power minus 6. The coefficient of linear expansion of the entire system. So for the total system of both the rods end to end, the coefficient of linear expansion is going to be 20 times 10 power minus 6. So the answer is option B. This is the answer. Okay, that's how you approach this question. So use the relation, find out what is the length at 100 degree Celsius, and find out what is the length at 20 degrees. That is as per the question itself. You will find out. This is 150, and then substitute. Okay, that's how you do it, children. Okay, just give me a minute, children. I'll just be back. I'll just use the restroom and come. Just give me 2 minutes. Once you then go through it. Yes, children, I'm back. So I hope you went through it. Okay. So the solution, this is how we do it. So moving on. Last one question we will solve and then we can wind up. Okay. So moving on to the next question. Question number 8. Okay. Yeah, here comes the question. Okay. A straight wire, a straight wire of length, a straight wire of length 0.5 meters. Okay, this is 0. 0.5 meters carrying current, carrying current 1.2 amperes is placed is placed in the region of magnetic field, placed in the region of magnetic field 2 Tesla. Okay, in the region of magnetic field 2 Tesla, they are placing a wire of length 0.5 meters carrying a current of 1.2 amperes as per the question. Now, the magnetic field is perpendicular. The magnetic field, okay, is perpendicular to the length of the wire. It's perpendicular to the length of the wire that they have mentioned. Then the force on the wire is. Then they're asking the force on the wire. Simple. Okay. So they are asking what is the force. So again, I'll give you the options. Option A, 2.4 newtons. Second option is 1.2 newtons. Third, 3 newtons. And option B, okay, that is the fourth option, is 2 newtons. So these are the options. So as per the question, what have they specified? Do you have a wire of length 0.5 meters? And then they've also given one more particular relationship. They've also given you the current through the wire. They have given you the region also where it is being placed. Having said all this information, they're asking you what is the force. Okay, what is the force? Simple. So what's the formula, children, for force of a wire placed in the region of uniform magnetic field? There is a formula. The force experienced by a current carrying conductor placed in the region of uniform magnetic field has a formula. I don't know if you guys remember. Anybody, can you tell me the formula? If you can recall it. F is equal to, yes. Somebody was trying. It's okay. You can tell me.
BQ.
Not BQ. F is equal to B
BIL sine theta.
BIL sine theta. Perfect. It's BIL sine theta. That's correct. Okay. So this is the formula, children. Now here, what about theta? What about the value of theta? They have not specified theta directly, but they say the magnetic field is perpendicular to the length of the wire, right? So having understood this, what can we take the value of theta as? They told it's perpendicular, right? So theta is equal to pi by 2, or you can say it is 90 degrees. Okay. So theta is 90. Sine 90, you all know that sine 90 is 1. So the formula becomes BIL. So go and substitute. What is the value of B from the question? We know that B is equal to 2 Tesla. So this is 2 times the current. I hope it was given as 1.2. So 2 times 1.2 into the length. And what was the length, children? It was 0.5. 0.5 can be written as 1 by 2. Right? So the 2 would get cancelled. And what's the answer? The force is 1.2 newtons. Is it clear? So that's the value of force. That's it. That's how you approach. Okay. So formula, again, the condition for theta, as per the question, they're saying it's perpendicular. So theta is 90. You substitute, we got BIL. Then we substituted the values of magnetic field, current, and length. We multiplied and simplified it. We got the answer of force is 1.2 newtons. So the answer is option B. I hope it's clear, children. That's how you approach this question. Okay. That's it, children. So, we have done different models, you know, questions. The electric current based questions, the circuit question is really important, okay, which we solved. So that's, a question uh, wherein they asked what was the total, power in that circuit. So that one, please practice. So that was a crucial one. And the conversion question of, the emitter. So like this, there are important ones. So we have discussed, major questions today in today's lecture. Okay. So please go through it. I hope, you guys have understood the approach to different questions in today's class. Okay. Yeah. So with that, we can wind up. Any doubts, children, you can ask. Okay. If you have any doubts, any queries, you can ask.
Thank you, sir.
Okay, children. Welcome. Okay. Take care. Bye bye. Until then, we'll meet up in the next
Thank you,
lecture.
sir.
Thank you,
Welcome.
sir.
Yeah, welcome. Welcome.